Very good morning friends, and in this video we are going to discuss about the trigonometry part 2. Part 2 means it is not just exactly part 2, it is just the extension of the trigonometry, and since it is incorporated into the video number 2, that's why I am calling it a part 2. Here we are going to discuss how angles are formed. So that to know that how angles are formed, we need to have a reference line. Reference line is a line which is just fixed. So this is my reference line, and this is pivoted at O. So you can say O is a fixed point and A is a rotating point. Now I want to rotate this point, see, like just like that. So that its tip starts moving in a circular path. So since I have to make this, so I will make a circle. It will be something like that. Then you can draw quadrants. Quadrant means you can divide the whole circle into the 4 parts, and these parts are called as quarters or quadrants. So this is what it is. So now so this means, just to see, OA is the rotating line. When the A comes here, I name it as A dash, means it's the same point A, but it has come from here. Suppose if I write A here like that and O here, then just see O is remaining fixed there, but the A is rotating and the angle is made like this is the angle, and it is anti-clockwise. Anti-clockwise angles are positive. So this is anti-clockwise, and anti-clockwise angles are positive. And if you go clockwise, then these angles are actually negative. So we are going clockwise. Sorry, we are going anti-clockwise. So now first I assume that my point has come at this point. So this OA, what you see there, now has become a hypotenuse if I draw a perpendicular from here like this, and this I am calling it as B. This is the foot of the perpendicular. When this is here, then the perpendicular from A to itself, so B is kind of here only. When you go here, when the A moves here, and then the angle becomes, this is A, I make this is prime, this is double prime, or A dash double dash. Then here this angle is theta, and this angle is, you can say, alpha. That is, alpha is bigger than theta. So now here the foot of perpendicular from here is B dash, and this is B double dash. So you see that when I am increasing, and since in the last video we discussed that the sine theta is just the ratio of opposite. So for this angle in the triangle O A dash B dash, the opposite is A dash B dash. So this is A dash B dash, and the hypotenuse is OB, you can say, or the OA dash you can say, or the O double A dash. It says all same. They are the radii of the same circle. But here in this case we'll say OA dash. So when angle is increasing, from here it goes to this. Now suppose if the rotating line A comes, so here you can say if you move from here to here, we will be traversing the angle 0 to 90 degree, and this is called as first quadrant. When the traversing point, when moves and then goes beyond this perpendicular line, again is tilted like that, then we say this angle is 90 to 180, and similarly this is 180 to 270, this is third quarter, and then it is 270 to 360 degrees, this is quarter 4. Now you know that the angles are measured in circular measure like that, which says that pi radian is 180 degrees, and then 1 radian is 180 over pi. So if you go for the full, so it's 2 pi is 360 degrees. So in terms of this radians, things are written like 0 to pi over 2. This is 0 to 90. This is pi over 2 to pi. This is pi to 3 pi over 2. And this is 3 pi over 2 to 2 pi. Now when you go beyond in the first quadrant, you see that if you use the coordinate geometry, idea of the coordinate geometry, then in the idea of the coordinate geometry, we take any point in the first quadrant represent as positive, positive. Here we represent it as negative, positive. In the third quadrant it is negative, negative. In the fourth quadrant it is positive, negative. So in this condition, if you measure the OA dash, that is positive, OB is positive, and A dash B dash is upward, that is also positive. But if you go into this quadrant, A triple dash, and drop a perpendicular like this, B triple dash, your angle is this, which is pi by 2 plus something more. I can say that this is pi by 2 plus alpha. It means this angle I take it as alpha. So this is pi by 2 plus alpha. Same way, when you come in this section, you will have your perpendicular moving like this, and the angle now becomes, because angle is always measured from the reference line. So this is our reference line and it has moved like this. So this is the angle, and this is, suppose if you call it beta, then this is pi plus beta. Now in the first quadrant you just saw that this is P positive, positive, this is negative, positive, this is minus negative, negative, and this is positive, negative. You know that when you're traversing, so sine theta, sine, cos, tan, sine is opposite upon hypotenuse. I can call it as O upon H, that is O stands for opposite and H for the hypotenuse. Cos theta is adjacent over hypotenuse, and the tan theta is opposite over adjacent. In this whole understanding, you will find that when you move the point from the one, so it's adjacent always goes along x-axis, and this is your opposite, that is the vertical, and the hypotenuse, using Pythagoras theorem you can find, so you can consider hypotenuse always to be positive. So now when the angle comes into this quadrant, then the sine theta, this part, so the opposite becomes positive but the adjacent becomes negative. So the cos will be negative here in second quadrant, because cos is opposite, sorry, cos is adjacent upon hypotenuse, and in this angle adjacent means when you move on this section, suppose here in this triangle, this is the triangle under consideration, then your adjacent for this particular angle is this, that is negative. It means the cosine is going to be the ratio of two sides where the one is negative and other is positive. Okay, so and then if you know that the tan theta is also sine theta over cos theta, tan theta is sine theta over cos theta. Now we are assuming that the radius is always positive, because Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. So if you find hypotenuse as the square root of perpendicular square plus base square, you'll always get two values, positive and negative. We discard the negative values, we consider hypotenuse always as positive. So the H, this section will always be positive. Only this part can be negative. On the left side, just using coordinate geometry, this is negative, this is positive, upward positive, downward negative. So when you come into this section, so here that if the cos is negative, so tan is the ratio of sine and cos, and if sine is all positive, because sine is opposite in this section, sine is opposite, this is positive because this is above x-axis, and the hypotenuse which is positive, so sine is also positive. And if tan is the ratio of sine and cos, and then one is negative, therefore tan is also going to be negative. So similarly, their corresponding inverted ratios like the cosec will remain positive, cot will remain negative, and sec will remain negative. So this way we say that here we use a common terminology just to understand this, say that here all t ratios are positive, that is A. Here only sine is positive, so we write AS. So all sine in the first quadrant, all t ratios are positive. In second quadrant, only sine is positive. In the third quadrant, now you see, in the third quadrant, when you see that this triangle here, then this adjacent is negative. This is negative adjacent from here to here. This is negative, and this opposite is also negative. So the adjacent is negative and the opposite is negative. And the sine is the ratio of opposite to the adjacent. So adjacent is negative, opposite is negative. It means only this tan will be positive because this is negative and this is negative. So here only tan is positive and all other t ratios are negative. When you come in your triangle into the fourth quadrant like that, then here you see this part. This is your adjacent, which is positive because it's positive direction of the x-axis, and this is negative direction of y-axis. That means this opposite is negative, and this is positive, and here hypotenuse we always consider positive. So now you see adjacent upon hypotenuse, that is the cos is positive, and all other ratios where opposite is involved that are negative. So here we have only cos is positive. So we see ASTC is just some people to memorize, say all silver teacups, just depending on how do you see, but I call it as all t ratios in this quarter 1, that is angle 0 to 90 degrees are positive. We go into second quarter, that is the pi by 2 to pi, or 90 degrees to 180 degrees, then the sine is only positive and it's reciprocal, that's cosec. And when you go into this one, then you find the tan is only positive along with reciprocal, that is called cot, or cotangents called cot. And in this one only you have cos is positive. So this is called ASTC. And now I need to clear this mess, and then I'll introduce you again in a different way, where we will be saying that the t ratios are positive in first quadrant. Means for the angle 0 to 90 degrees, all the t ratios are positive. For the angle 90 degrees to 180 degrees, only sine is positive along with the cosec, which is its inverse ratio, and all other are negative exactly. So here in third quadrant, between 180 degrees to 270 degrees, or in terms of the radians, pi radian to 3 pi over 2, only tan is positive, all other ratios are negative. And opposite of tan, of course, will be positive. So the tan and cot will be positive. Here cos and sec will be positive. This is all for this basic. So this is my coordinate axis. I call it as x dash o x. This is positive direction of x-axis. This is y o y dash. So here you saw that in the first quadrant, that is 0 to pi over 2, all t ratios are positive. And here pi by 2 to pi, only sine and its reciprocal is positive. In the third quadrant, you have pi and 3 pi over 2, so only tan is positive. In the fourth, you have 3 pi by 2 to 2 pi, so there only cos is positive. Now, what kind of questions come from this section? Now, suppose you are given a question like sine x is 12 by 13 and x lies between pi by 2 and pi. Find all other t ratios. So when you see that x pi by 2, just locate the angle x. So this lies in the second quadrant because this is between pi by 2 to pi here. so the sign is positive, and you know that all other. So first I try to find out the cosec. So cosec x will be 13 over 12. This is positive. Now I have to find cos. So how to find cos? So cos you can find there two ways. Either you just draw a tiny triangle like this. This is x, and if this ratio sin x is 12 over 3, so opposite is 12 times a constant value, and hypotenuse is 13, a constant value definitely. So I can call it as 12 constant and 13 constant. And then if you use Pythagoras theorem, so you'll find that this square minus this square, so 169 k square minus 144 k square, and then under square will become, suppose I call it as a. So I have a relation like 169 k square, this is hypotenuse square, is this square, that is 144 k square, plus this square which is a square. So you get a square is 25 k square, and if you find a, then you get the plus minus 5k. So here we take a as 5k. Okay, now when you're trying to find out the cos x, so cos x here in this case is 5k over 13k. 5k over 13k, k cancels, so it's 5 over 13, and since it is in the second quadrant, then this is going to be negative. Done. Then sine over cos is your tan. So tan is minus 12 over 5, and then cot is just reciprocal of tan. Then this is minus 5 over 12, and then sec will be minus 13 over 5. Sec x is minus 13 over 5. This is it. Now these t ratios also have certain relations. For that, let me clear this screen, and then I'll explain you what kind of relation directly exists between all t ratios. So now I'm just trying to establish what kind of relation exists directly between all t ratios. For that, first I have to draw a triangle, a right angle triangle, of course. This is my right angle triangle, ABC, right angle at B. So the AC is the hypotenuse, AB is the perpendicular, and BC is the base in the normal terminologies, because we assume that the BC is horizontal, horizontal is something related to the ground, therefore this is your base and this is your height. In terms of angle under consideration, suppose this angle is theta, then we can call this is opposite. So this is opposite to this angle, and then this is adjacent. BC is adjacent to this angle, and the AC is hypotenuse. Any terminologies you can use, it's all depending on how do you take the whole thing. So now the direct relations given by Pythagoras is AC square is equals AB square plus BC square, and everybody believes in this theorem because it has been proven correct, and nobody till date have been able to prove it wrong. So this theorem is correct. So now what I do that, if I divide this equation, this is the equation where AC, AB are the variables. So if I divide both sides of this equation by, suppose first I divide by hypotenuse, so AC square. So I divide this AC square and this AC square. This becomes 1. Now AB over AC, AB is opposite, and AC, AB over AC, that is perpendicular upon hypotenuse, or the opposite upon hypotenuse, that is sine of theta. So you can call it as sine theta, because sine theta is AB over AC, and this is square, that's why it is sine square theta. And this is BC over AC, that is cosine, that is cos square theta. This is one relation you say existing between them. This is sine square theta plus cos square theta is 1. Now instead of dividing this equation by a square, AC square, if I try to divide it by AB square, then what I'll get? I get AC square over AB square is AB square over AB square plus BC square over AC square. Now AC over AB. What is AC? AC is hypotenuse and AB is this. So AC over AB is just reciprocal of sine, that is cosec. So this is cosec square theta, and then this is 1 plus BC over AC. BC is adjacent and the AC is hypotenuse. So the adjacent over hypotenuse is what? This is AB square plus BC square. Oh, sorry, my bad. This should be AB square. Okay, so AB is BC square over AB square. BC square over AB square. BC over AB, and AB over BC is called as tangent. So the BC over AB is called cotangent. That is also written as cot square theta. This is second relation existing between them. Third relation is, instead of dividing by AB square, so see, I have the relation AC square is AB square plus B square. First I divided both sides of this equation by AC square. Now I am dividing both sides of this equation by AB square. So this times I will be dividing both sides of this equation by BC square. So what I will get? AC square over BC square is AB square over BC square plus BC square over BC square. Now AC square over BC square, AC square over BC square. So this is hypotenuse and this is base. So base upon hypotenuse is cos and hypotenuse upon base is sec. So this is sec square theta. AB over BC, AB over BC. This is directly AB over BC. This is tan. So this is tan square theta and this is 1. This is one such relation. Now the next relation is such tiny one. This says that, sorry, I say tan theta is opposite upon AC. So it is opposite upon BC adjacent. Now if I divide this fraction, both numerator and denominator, by quantity called AC, then AB over AC is sine. So this is sine theta and this is cos theta. So the tan theta is sine theta over cos theta. Now again coming back, so this relation you keep in your head. Sine square theta plus cos square theta is 1. Sec square theta is 1 plus tan square theta. And the cosec square theta is 1 plus, if you want to memorize this, you can write only these three equations, and then I'm coming back to just explain you next type of thing, that is how to solve a question using this formula rather than using that previous triangle method. So suppose I have a question now, and using the previous discussed thing I am just going to get the answer. So the question is that, suppose if tan theta is 3 over 4 and theta lies between pi and 3 pi by 2, means third quadrant. So you can just draw a tiny reference point, A, S, T, C. Our theta is here, more than 180 or pi and less than 270 or 3 pi by 2. Then we have to find all other t ratios. So first, using the relation, just you saw the relation that sec square theta is 1 plus tan square theta. So now it's 1 plus 9 over 16. If you square 3 by 4, you get 9 by 16. So if you just add up, it will become 25 over 16. So this is sec square theta. Now sec theta is plus minus under root 25 by 16, that is 5 by 4. So because when we are taking square, it always gives you two set of values, positive and negative. So sec theta is giving us value 5 by 4, and in the third quadrant only tan is positive, so sec is going to be negative. So we'll discard this positive value. So our accepted value is sec theta is 5 by 4. Now when you have found sec, you can find cos. Just reciprocal it. Cos theta is 4 over 5. You found this one also. Now tan theta is already given, just you reciprocal it, you'll get cot theta. So cot theta is 4 over 3. 4 t ratios we have already found. Now we are going to find the final one, that is sine. and cosec. So again a relation established between them is sine square theta plus cos square theta is 1. Therefore cos square theta, this cos square theta is 4 over 5, so this is 16 over 25 is 1, and this is sine square theta plus, so sine square theta is 1 minus 16 over 25, that is 9 over 25, and this is sine square theta. So sine theta is plus minus 3 by 5. Now in the third quadrant we'll directly reject the negative one, so sorry, positive one, then we accept only this. Sine theta is minus 3 by 5. Now I made a silly mistake here. Tan is only positive, so instead of discarding this positive one, we should have discarded the negative one, so this is just negative. Same way here, cosec theta is the reciprocal of this one is minus 5 by 3. Now see, we are in the third quadrant, and here only tan and the cot are positive, all other t ratios are negative. This is how you can use this idea. And now in the next video we will discuss about the compound angle, double angle, multiple angle, and the sub-multiple angles in a different video. Thank you very much. Subscribe to our channel and keep practicing with us. Have a very nice time.